This video is about application of compound interest formula. Here is the formula for compound interest. Future value equals present value times 1 plus R over 100 times K to the Knth power. This K is the number of compounding periods per year. Yearly or annually compounded, K equals 1. Half-yearly compounded, K equals 2. Quarterly compounded, K equals 4. Monthly compounded, K equals 12. N is the number of years. R% is the nominal annual rate of interest. 1. Tom and Peter have each been given €1,500 to save for college. Peter invests his money in an account that pays a nominal annual interest rate of 2.75%, compounded half yearly. Calculate the amount Peter will have in his account after 5 years. Give your answer correct to 2 decimal places. We will use this formula. We are given PV equals 1,500. R equals 2.75%. K equals 2 because this is a half yearly. N equals 5. So FV equals 1,500 times 1 plus 2.75 over 100 times 2 to the 2 times 5. Let's organize a little bit before we put it into calculator. 1 plus 2.75 over 200 to the 10th power equals, enter. Peter will have €1,719.49. Let's go to B. Tom wants to invest his money in an account such that his investment will increase to 1.5 times the initial amount in 5 years. Assume the account pays a nominal annual interest of R% compounded quarterly. Determine the value of R. We are given future value equals 1.5 times 1,500 equals 2,250. Present value equals 1,500. K equals quarterly, K equals 4. Compounding 4 times per year. N is 5. Now we plug into this formula. 2,250 equals 1,500 times 1 plus R over 100 times 4 to the 4 times 5. Organize before we go to equation solver. 1 plus R over 400 to the 20th power. Let's type the equation into calculator. Control menu. Enter, enter, enter. No solution found. Retype this equation into this calculator. Control menu. Enter, enter. This time you need to put a number into this gas. Let's do the 10. Then enter. they will give you correct answer 8.19. R equals 8.19. Example 2. Andrew has $520 in his saving account. Andrew considers investing the money for 5 years with a bank. The bank offers a simple interest rate 1.2% per year. Calculate the amount of money Andrew would have at the end of 5 years with the bank. Give your answer correct to 2 decimal places. Simple interest means the same interest, 1.2% times 520 equals $6.24. This is interest per year. Future value in 5 years equals 520 plus 6.24 times 5 equals $551.2. Let's go to B. The bank offers an annual interest rate of 1.2% pounded quarterly. Quarterly means K equals 4. Calculate the amount of money Andrew would have at the end of 5 years with the bank. Give your answer correct to 2 decimal places. We will use this formula. We are looking for FV. PV, present value, is 520. K equals 4. R percent equals 1.2%. N equals 5. So FV equals 520 times 1 plus 1.2% times 4 to the 4 times 5's power. Organize. 520 times 1 plus 1.2 over 400 to the 20th power. Let's go to calculator. Enter. 552.11. Give your answer correct to 2 decimal places. So we got $552.11. Instead of investigating the money, Andrew decides to buy a phone that cost $520. At the end of 5 years, the phone will have a value of $30. It may be assumed that the depreciation rate per year is constant. Calculate the value depreciation rate of the phone. Exponential growth. Future value equals present value times 1 plus R percent to the nth power. For exponential decay, future value equals PV times 1 minus R percent to the nth power. N means number of periods. Sometimes means years, sometimes means month, sometimes means weeks, and so on. For this question, we could say this is exponential decay. We are given future value equals 30, present value equals 250, and n equals 5. We will put into this formula. 30 equals 520 times 1 minus R percent to the 5th power. We will put the equation in, then control menu. Enter, enter, enter. So R equals 43.5 as a 3-sig fix. By solver, R equals 43.5. Depreciation rate is 43.5%.